everyone. So today I'm going to teach you L'Hopital's rule for indeterminate quotients. That seems like a bunch of gibberish for a person who does not even know a little bit about what this means. I'm going to start with just talking about plain old limits. Now, if you've been taking calculus, we know limits comes again and again and again. And there's many different types of limits, okay? Usually we get limits in the form of something like this, right? We have lim, okay? X approaching any number. Let's say that's a. And we have some sort of function, and we're going to name that function f of x right now. Okay, so this is what, usually our situation is. Now, how we usually solve this is that we take this number, we plug it in, and we spit out the answer, and all's good. But in some cases, that doesn't really work out, okay? So now, let's say we have an example where we do have a function f of x, but we have a dividing line, so the division line, and we have a different function. Okay, so in this case, we're asked to find the limit of f of x divided by g of x. Now, both of these are different functions. They're continuous functions. You have to remember that. And x approaching any number, let's say. Now, we follow our same routine. We take a, we plug it in f, we figure out what it is, figure out what g is. Now, sometimes we don't get numbers when we do this. We don't get a finite number when we just plug an a into the original f of x and g of x, okay? Sometimes when we plug an a into f of x, we get f of x to be 0 or positive, negative, infinity, okay? And then at the same time, when we plug that same number into g of x, we also get 0, positive, negative, infinity. And we're kind of stuck because we kind of have a situation where we have 0 over 0 at x equals a, or we have positive, negative, infinity and positive, negative, infinity. We're stuck after this. We're like, well, what do we do? In this case, you don't have to worry. There is something that is going to save you, which is the L'Hopital's rule. Now, if we look at over here, this is a quotient. This is a quotient, right? What we call this situation, we call this 0 divided by 0, infinity divided by infinity, and indeterminate, okay, we call this, sorry, my spelling is off, indeterminate, okay, form, but this is not just any indeterminate form, this is an indeterminate quotient, okay? This is an indeterminate quotient. So that is where I get the indeterminate quotient from the title, okay? Now, obviously, indeterminate forms come in many different shapes and sizes, just like people, okay? So they come in, indeterminate forms can come in like 0 multiplied by positive, negative, infinity, or we can have 0 or something to the power of infinity. Basically, what I'm going to be teaching today is just applying indeterminate quotients. Like the L'Hopital's rule is just going to be helping us with indeterminate quotients. Now you might be asking, she's rumbling on and she's not telling us what we actually do. What we actually do in these situations, okay, is that we take the derivative, okay, we take the derivative of f of x, okay, we divide by the derivative of d of x. Now, I'm assuming since you're watching this video, you know what derivatives are at this point. So we do something like this. And then we plug, chug, spit out the answer, and we're good. Now, let's do an example to kind of, help this set in our brains, okay? So we have an example. We have to find the limit, okay? We have to find the limit of ln of x over x minus 1, and over here, x is approaching 1. So what we do, our first step is, okay, you know what, let's plug in 1 into f of x. Oh, well, actually, before we do that, we see that ln of x is a function, so we have a function, x minus 1 is a function, okay? So we have a function divided by function, Perfect. Now we plug in 1 in the top. Okay, ln of 1 is, we all know, 0. And we plug in 1, we get 1, at the bottom, we get 1 minus 1, which is 0. So we get an indeterminate form. So we can apply, okay, L'Hopital rule. Okay, now we usually do this. I'm just going to copy the example over here. To indicate that we are, in fact, using the L'Hopital's rule, we have a little bit of, like a symbol. We have an equal sign. You can put an H on top. Some people like LH, but you know what? H is fine. Okay, so we plug in, we plugged it in. We found that this is an indeterminate form. Now we find the derivative of ln of x. Derivative of ln of x, we know, is 1 over x. The derivative of x minus 1 is just 1. Okay, so now we have just the plain limit 1 over x. We plug in 1, we get 1 over 1, and the answer is 1. So now you see how this situation got simple by just applying this teeny tiny rule that we were all overrun by the title that I first talked about. So to recap everything, if we have a function divided by a function, and in this case they have to be continuous, and both of those functions either go to a positive, both goes to positive and negative infinity or zero, we have an indeterminate quotient. Okay, then we use the L'Hopital's rule for indeterminate quotients, which is find the derivative of f of x divided by the derivative of g of x, okay, and solve the limit. Then we did an example over here, and we made sure that we can even use the L'Hopital's rule. Sometimes the books can trick you. Sometimes it seems that you can use the L'Hopital's rule just by looking at this, but, and sometimes you can simplify stuff. And so just make sure and plug in the A value that you have over here and figure out what to do. And hopefully this video helped. If this helped, that is great. And have a great day.